Welcome to the third session of the day. I'm Elizabeth from Business Helsinki, host of the Finnish Technology Landscape track today. And for this session, we have brought you two speakers. We will start with our first speaker, have a Q&A, and then continue with our second speaker in around 1 hour, 45 minutes. So our first speaker is Galina Leväsluoto, and she is the head of talent acquisition at IQM Quantum Computers. Galina will introduce us into quantum computing and its applications and share with us about the developments and opportunities at IQM, as well as resources through which you can learn more about the quantum space and gain skills needed in this industry. You can type your questions in the Q&A section already during the presentation, and we will take them at the end. Again, if you cannot access the Q&A, try changing your browser or updating your app. At this point, I give the floor to you, Galina. Warm welcome to this session.
All right, thank you, Elizabeth. Hello, everyone. Welcome to this session. I'm Galina. My title at IQM is Head of Talent Acquisition, and today I am, of course, coming to talk to you about quantum computers built for real impact. So we have 20 minutes before the Q&A, so actually I prepared to take you through, but Elizabeth nicely summarized that. So I'll start with a quick intro into quantum, not too much into details, but just a few basics so we are all on the same page. Then I move on to IQM, what kind of company we are, what kind of products, customers, partners we have. I will speak a few words about careers at IQM, hiring, what kind of roles, and so on and so forth. This is something that I lead in the company, and as a final part, I'll say a few words about breaking into quantum, so share some resources with you. And let's start with a background. So first, I'd like to clarify a few things. So what is quantum computing? And nowadays we have classical computers as well as quantum computers, but classical computers, basically you can think about anything, your phone, your laptop, your personal computer, so things that you use every day, to AI factories, exascale supercomputing centers, so like a very, very powerful classical machines. And then we have quantum computers, which is a new development in the technology. Quantum computers follow different rules than classical computers, rules of quantum physics. And one thing that is very important to clarify, and why is it so different? So when you talk about classical computers, we use bits. Bits can either be 0 or 1s, while qubit can be both. And that's what we call a superposition. I think the best description that I heard when I was myself learning about quantum is, if you think about a coin, it can be either head or tail, or tails, but then you flip it, it's actually technically both at the same time. Once you have it on your hand or you have it on the table or wherever it lands, you will either see head or tail, and that is what we kind of can refer to as measurement. So measurement of quantum bit will yield either 0 or 1. However, what we are trying to foster here is that superposition, or rather when the coin is flying. Two qubits can be entangled. So entanglement state is a very important aspect of quantum computing. And once the qubits are entangled, changing one, so sending a pulse to one, will directly impact the other one. So this is actually two things that we are trying to understand within quantum hardware, so qubit measurements and entanglement. Why am I talking about this and why is it important? So basically, if we talk about two qubits, they can represent 4 numbers already at the same time. And then, you go forward, and with 3 qubits, you're going to have 8 numbers, and 9 qubits already get you to 512 numbers simultaneously, which is quite impressive when we compare to the classical computers once again. And so technically, just 50 qubits then outperform the conventional computing. So you may wonder and ask, so why didn't it overperform the classical computer yet? So the reason for that is these qubits will need to be all in superposition, and we as a scientist, or we as people, will need to make sure that we are able to explore the entire space of these qubits reliably, and kind of be able to measure and read all of the information there. So this is what we refer to as quantum advantage. To sum up these things, basically, if we, once again we compare, so only few qubits already exponentially increase computational capacity, and also qubits enable us, and they enable new algorithms and solutions which were previously not feasible with classical computer. So I'll speak a few things about quantum algorithms. So once again, here I'd like to refer to quantum algorithms and classical ones. And the biggest difference is actually quite similar to when we think about qubits. So classical algorithms typically operate sequentially, so one step at a time, one after another, and which can be much less efficient for certain problems. So for many problems, classical algorithms are very efficient. But for some, then quantum algorithms step in, and then it unlocks more power here as well, or rather exponential speed up, what I would say. So quantum algorithms leverage the superpositions and entanglement to enable new algorithms and manipulate qubits via quantum operations, or what we call gates. And you can see the 1 qubit gate and 2 qubit gates at the left bottom corner there. Quantum algorithms explore superposition of solution paths simultaneously. So once again, this is very important to, certain domains like optimization, simulation, machine learning. So this is already unlocks quite a bit of things. And quantum algorithms use interference to enhance the likelihood of measuring correct solutions. So as I mentioned before, measurements here is the problem that we are tackling, not just us at IQM, but community in general. So here I'd like to move on a bit from this theory and introduce you to a few quantum computing players. So there are several types of quantum computing technology, or several types of qubits. There are superconducting ion traps, photonics, and Miller's neutral atoms. There is actually more coming up, I think, every day. Okay, not every day, but quite often. So I will not be concentrating here on majority of those. I'll speak just a few words about superconducting qubits and architecture. This is the one which is currently the most promising. We just got another confirmation, or another hint, so to say. The Nobel Prize winner were three researchers which have published a paper on the superconducting computers, superconducting qubits. All major players invest into superconducting qubits too. So from maybe this slide, you can see there is IBM, there is Fujitsu, there is Google, there is IQM, and a few others. And maybe one of the additional one. So how it works, it uses charges or current and energy of superconducting circuits. It's manipulated with electrical energy, and the closest to classical computing chips. So that means that it has the biggest feasibility of manufacturing and actually producing the hardware. Now that we talk about all of these things, just wanted to go into applications of quantum computing very briefly. So again, if we talk about classical computers, there are a few commercial problems that can never be solved pretty much with classical computers. There are fundamental limits of those. So there is just simply not enough atoms in the universe to build a large enough memory, and the time and power limits. So computing the answer will take billions of years, and it would take crazy amount of energy and water consumption. So, too expensive, a lot of energy consumption. And when I'm talking about this things, so a few ones: logistics, electrical vehicles, for example, as well. So battery research is something that we definitely tackle at IQM and as a community. And then other one maybe many people can relate, as we just went through pandemic. So it's superior computational power for fraction of energy consumption for pharmaceutical and for medical research. So here is a few industries where we see quantum computing game changers. Now, would like to move on to IQM specifically. So at IQM, we tackle all of these problems, all of these challenges, and our mission is as the following. So we build world-leading quantum computers for well-being of humankind now and for the future. So all of this, pharmaceutical, logistics, energy consumption, clean energy research, these are some things that we are tackling in the company. And it's very important for us. Now, if we talk about what kind of company we are as well, so in numbers, also very briefly, so we were founded in 2018. The company itself started operating in 2019, and we have been international since day one. So our company language is English. We have been, hiring abroad, relocating people to Finland, relocating people to other countries that we have. Right now, we are at 320-ish, a bit more employees. We are actually quite educated. So out of the entire workforce, we have 132 PhDs, as I know right now, very well funded. So we recently raised our Series B, which was one of the largest ones in the Nordics and in quantum in Europe. We have successfully built 30 plus full systems, and full systems where I mean full stack quantum computers, which I will talk about a bit later. And we have sold and installed quite a few systems there as well. We also have cloud platform, and there we have quite a few users nowadays. So I will not go too much into that. So talking about international, so we are a Finnish company originally, so our headquarters is in Espoo. That's why we are happy to participate and support the event today. However, we used to call ourselves pan-European. Our other very important location is in Munich, Germany. So there we have also quite a few people. And for the past few years, we have been expanding internationally quite heavily. And expansion not just means, that we establish an entity and we sell and install our quantum computers in all of the countries that you see here, but also we are hiring talent, working with the community, working with the universities, and so on and so forth. So apart from Europe, we also have an office in the United States, and in Asia Pacific, we have right now South Korea, Japan, and Singapore. And in the process to expand in Taiwan, we are actually hiring right now. Not sure if there is anybody in the audience from there, but just wanted to maybe a good point to tell. Some of the customers and partners that we work with, so you can see that we work mainly with research labs, universities, and HPC centers. However, we have quite good partnering and backing from the very big enterprises as well. So probably many of you know NVIDIA, AWS, and HPE. There are some which are also more European ones like Eviden. There are some from Asia Pacific like ICE from Japan. And again, universities and scientific community is also super important for us. When we talk about product portfolio, so I mentioned that we have full stack quantum computers. So we have IQM Spark, which is targeted for education. So for universities, if they want to, educate their own workforce in the country, or they just have a university where they work on quantum algorithms and they would love to run it on quantum hardware. We have a product for that. We have our flagship IQM Radiance, which you saw in my opening slide. So this is a best performance and high fidelity, so which is a bigger machine right now, up to 150 qubits. That's what we are delivering. And then we have IQM Resonance, which is our fully owned cloud platform. So we have it hosted at IQM premises. It's very secure. It's quite low cost for many enterprise customers. But main thing about all of these products that they're transparent and easy to use, and we leave them as open source as possible. So we are quite open with our hardware and our software. Now, I talk quite a lot about quantum computing and IQM. So maybe to wrap up to some extent, we are hiring, we have been growing for quite some time, and we don't want to stop growth here. So we are hiring in Finland, we are relocating people. So some of the roles that we're usually targeting is, of course, quantum engineers. It can be algorithms and can be QPU, so quantum processing unit. It can be experiments. Also, we have a quantum computer control electronics stack. We have, electronics engineer, hardware engineers. Our software stack goes from a very low level firmware to up to user interfaces. So everything in between there. We also are always on the lookout for commercial experts and all sorts of roles. So I think I will do myself a favor and not talk about every possible role that we have. You can go to our careers page or scan the QR code. So our recruitment process, usually we try to keep it as transparent as possible. So usually it's 4 steps. If you apply, if you get into the pipeline, you will be thoroughly reviewed by the hiring teams, which consist of experts. Then you will have a reply from our talent acquisition team, sometimes maybe from me, sometimes from some of my colleagues. And after the first conversation, we generally have many times we have a tech challenge or technical interviews, then meeting the hiring teams and reference check, background check, and offer. And let me see. I think these are the main things that I wanted to tell, and also being a bit mindful of time, I'll move on. So here, I wanted to let you know that for the quantum job openings, we are happy to hire everyone we see. However, as you maybe can imagine, this is a very niche field. So for every one qualified candidate in quantum computing field, there is 4 quantum job openings, which is quite crazy. So at IQM, we are trying to tackle that in many ways. So we also provide internships. We also have, more junior roles, but we specifically also wanted to create something of our own. We participate hackathons as well, but we decided that this year we want to have an IQM Quantum School, which is a 3 days workshop for launching your quantum career. And the course is designed to build your understanding on quantum computer much better than what I explained in the beginning of this presentation, as well as give you some hands-on experience. So actually our cloud platform has a free trial, for example, but this one will give you more access and more an ability to play around. So it's going to be in December, approximately 4 hours a day from 2nd to 4th. It's going to be fully live. There's going to be Q&A, and actually anybody can sign up. So if you like this presentation, maybe I recommend you checking it out. There is once again a QR code, and I think I can maybe share some links after this presentation. And finally, if you, for example, cannot make it, we also have IQM Academy. So this is something that we have been working on from quite a long time, since the early on, because we do think that it's very important to make sure that we have enough of the workforce also moving forward, not just right now, but moving forward. Once again, as I mentioned, we are an open source enthusiast. Maybe something that I'm looking for. So there is quite a few things, quite a lot of tutorials, which you can also take at your own pace. It's easy to pick up. You don't need to have any previous knowledge. And we also try to always have it gamified and as engaging as possible. And with this one, I would like to say thank you very much. I posted my LinkedIn over here. I had some troubles connecting to the platform, but would be happy to stay in touch with you. Send me a message on LinkedIn. Always happy to connect and talk about quantum, I guess. Thank you very much.
Thank you for this very informative presentation, Galina, and congrats for completing the funding round.
Thank you.
I was wondering about the applications of all of this. You mentioned the clean energy and some other things. We hear a lot of things that are maybe a little bit hyped. So what is the reality of those applications? And like in the next decade, what do you see like coming in terms of applications that we will, like in our day-to-day life, see tangibly? Is there something coming to your mind?
Right. So for the day-to-day life, I think it's probably going to take a few years or so. Nowadays, we talk quite a lot about quantum error correction, and fault-tolerant quantum computing. So that means this is going to be, I've been talking today about few qubits up to 50 qubits, but this is where we talk about, thousands to millions of qubits. And then you have basically these machines which have error correction in them. So this is where we going to see real impact. And if we talk about nowadays, it depends on how you define an application, right? So if we talk about the everyday life, it is true that it's going to take us some time. We do see benefits of quantum computing already when you integrate them into HPC, so high performance computing centers. So they already unlock some power for the classical computers, or forgot what you call it, combinational computer. The word is escaping me. But if you talk about logistics, green energy, finance, automotive, so there's quite a few sectors which are explored right now. I would say we will, as us humans, we will probably feel effect in, I don't want to give it a timeline, but maybe 5 to 10 years at least. I'm like, if somebody's going to quote me, then I'm in deep trouble.
We will discuss this again in 10 years and see what has happened.
Exactly.
Cool. So you mentioned that there are also internships that you provide. Are there also any thesis project? Do you take students who are doing thesis on something relevant to you?
Right. So for us, we actually also have a few PhD people who have been, going through a PhD simultaneously while working at IQM. So, and master thesis and thesis projects, we will consider. It does have to be quite beneficial for the company. So it's not always easy to find this kind of topics. However, I think the easiest way is to get into the internship, and then we actually have a tendency to retain our interns. I think it's all the companies. I don't think it's only IQM, but we have this kind of cases where people left and came back once we graduated or just stayed.
Yeah. Is there an internship program, or does one send you an open application, or how does it work?
Yes, so we have an internship program, and this is going to be announced closer to December and January. So we take maybe dozens of interns. So we are not a big company. We don't take, hundreds of thousands. We are 320-ish people. So that means that we will take a few interns, but basically I would recommend, unfortunately, don't have a better advice apart from please follow our careers page, and we will post our internships there. Yeah.
And you mentioned about the quantum school and the academy, really nice initiatives from you. And the quantum school was online, so anybody can participate from anywhere, 2 to 4 December. And there was a question, is there a realistic possibility to get hired by you after passing a course?
Right, so it depends. So I will just, actually, I don't know if people can still see my slides. I just went back to the quantum school.
It's visible.
So we are hiring hundreds of people, actually. So it is true that it's quite competitive field. However, we are very interested, and also I myself go through quite a lot of applications. So is my team, so is the team at IQM, because we're hiring a lot. So everyone has to go through quite a lot of people. And really, people who go through IQM Academy and who go through these sorts of events, they do stand out. And we have quite a good track record of people who actually, participate hackathons and participate in this sort of event. Usually, they just show this genuine interest in quantum computing, and it's very important for us that people are actually interested. So it's not just another application or just another job for them. And I do believe that you have a better success chance in getting hired if you participate in those. And specifically for IQM, this is what I can tell. I don't know about other companies, but for us, definitely.
Yeah. And can you share a little bit more about the skills that are taught in this school?
Right. So I think the best thing is to also get into the QR code. So a few things is because this is for people who don't have a prior experience in quantum. So for sure, there will be maybe similar content, but very much more in depth and much more in detail that I could share now in a few minutes. So all of the fundamentals. I think for us, it's also very important. So we have our cloud platform, and there it's very open to how you can, design a qubit, how can you interact with qubits. We have a pulse level access, which is quite important for the scientists to measure all of the things. And so we will go through all of this during this 3 days workshop. And once again, so you get theoretical knowledge and also then hands-on, writing your algorithm or, manipulating your first qubit.
Sounds very good. And is there any connection between this quantum computing and AI? Is there anything there? How do they connect, or do you use any AI tools for this?
Right. There is definitely quite a lot of connections, and I would say quantum computing is going to be a next wave. If you think about technology development, then you have classical computer, you have AI, you have GPU, you have I forgot blockchain. I was like, what is the appropriate name for that? And each wave of this new technology development builds on one another. For quantum computing and AI, it's definitely powerful. So I mentioned super briefly that nowadays you probably see many big players are building the AI factories. So this is where quantum computers are going to be also integrated. And this is where a lot of kind of fruitful research is going to come out. Of course, within the company or for a lot of things, we will be using AI tools, if this is what you're asking. But there is even a bigger part of it where quantum computer can accelerate development of AI.
Yeah. Interesting to hear how these relate because the AI tools are being discussed in all our sessions. Yeah, so nice to also see how is it related to this. Then how about the people that you are hiring? How important is the experience that people have? Like, can a junior person with not much practical experience join you? Do they have a chance, or do you go for seniors, or well, how does it look like?
So it's again, quantum computers
Hard
is
question.
that much different. So it's the thing is that quantum computing is also so new that there is simply no people with 20 years of experience in quantum computing, right? So this is a new thing. So that means that in traditional sense, these people are not senior, they don't have 30 years of experience behind them. However, if they have completed the very relevant PhD, they are the most senior for us, right? So it's very important for us to also, we hire people straight out of masters, straight out of PhDs many times. Again, I mentioned that some people even completed the PhD with IQM. So for us, in that sense, in terms of years of experience, it's not the most important thing. And generally, I cannot even stress enough soft skills, right? So it's very important for us that people are interested in the field, that they are curious, that they are resilient, they are able to break into this field that has, like, they are motivated by something that has not been done before. So this is actually many times certain types of people. So not everyone is comfortable with these sorts of companies and these sorts of environments. So these are also the skills that we are looking for. If we talk about more traditional roles in, let's say, hardware engineering, software engineering, I think we also hire juniors and seniors. So we have quite a few interns as well in our software team, for example. And I think about it, we have mechanical engineering interns right now. So we really, it's a good mix of people, I must say.
That sounds like a good place then for juniors, such a kind of emerging industry.
Yeah.
Yeah. And there's a question about the jobs being on-site or remotely. How do you manage that?
Good question. Excellent question. So because we build full stack quantum computing, so that means that we have our own fabrication facility in Espoo, for example, and these jobs, some of the jobs you just simply cannot do remotely. So it will require you to be in the lab. It will require you to, troubleshoot, to debug, and it's quite beneficial to be in the same place with the rest of the team. So for majority of roles, I think we have hybrid setup. So many times we are either in our Espoo office or then in Munich, there is quite a lot of people, as I mentioned. Some roles, especially sales roles, actually are fully remote because they require quite a lot of traveling. And then we also have quantum solutions. So that's going to be technical people who also would go to the customer side, who will need to explain to them what can quantum computer do for you, what is the benefit, and so on and so forth. So these type of roles are generally remote, and generally people work from the home. However, they also travel quite a bit.
Yeah, so it depends on the role then.
Yeah, we usually specify.
Yeah. And there was a question about the registration for the December school. So was it that it's already on, like registration is open?
So I have a QR code over here.
Yeah.
So for I can maybe also send the link in the chat. There is one over there. And now that I'm thinking about it, I should have a different QR code. This one, because there is also, I forgot to mention that we usually have the specific QR code for events. So basically, if you are a participant of this one, this is not a job which is posted on our website, but this is event specific. So if you leave your contact details there, then we're gonna know that you're coming from this event. Otherwise, we have careers, and you can find all of the roles that we are currently hiring for on our website.
Really nice benefit for participants here.
That's true. I didn't advertise enough. I'm like, what am I doing?
What about the roles in your team, like in talent acquisition, HR roles? Are you hiring there?
We just hired quite a few people. I must be honest. So I actually have 2 new people on my team which I hired recently. We also hired on the people ops space, so HR. I'm just thinking we probably will have a few roles next year. So I recommend maybe keep once again watch this space, and we will usually post all of the jobs that we are hiring for.
Yeah, all the information is online.
Yeah.
Last question about the IQM name. Where does the name come from?
It's a top secret. It's more secret information than quantum computing.
Is it a part of your algorithms?
Yes, exactly. I think we should have a challenge on our website, kind of guess where is the name coming from, and then you're immediately hired.
Yeah. Nice game. All right. Thanks a lot, Galina, for this presentation. And